Beneath Pluto's mysterious surface, an ocean of possibilities. Pluto's heart-shaped Tombaugh Regio may indicate that the dwarf planet harbors an ocean beneath its surface, say scientists. Pluto's famous heart-shaped feature caused the dwarf planet to roll over the eons, and this reorientation probably wouldn't have been possible without a subsurface ocean, new research suggests. Welcome back to Tech Trends for All. Before we proceed, kindly subscribe to our channel and hit the bell icon to stay updated when we release new videos. Without further delay, let's dive in. The left lobe of Pluto's heart is a 600-mile wide, 1,000 kilometers, plain called Sputnik Planitia, formerly known as Sputnik Planum, which astronomers think is an enormous impact crater. This basin has been filling with nitrogen ice over the years, and now contains huge amounts of the stuff. Indeed, observations by NASA's New Horizons spacecraft, which flew by Pluto last year, suggest that Sputnik Planitia's ice may be up to 6 miles, 10 kilometers, thick. Pluto's reorientation would have stressed the dwarf planet's crust, leading to a network of faults and fractures on the surface, Keane and his colleagues report. And New Horizons spotted just such a network, whose characteristics match those predicted by the team's models, they said. When NASA's New Horizons spacecraft zipped past Pluto in 2015, it showed a world that was much more dynamic than anyone had imagined. The dwarf planet hosts icy nitrogen cliffs that resemble the rugged coast of Norway and giant shards of methane ice that soared the height of skyscrapers. Cracks deeper than the Grand Canyon scar the surface, while icy volcanoes rise taller than Mount Everest. In one part of the distant orb, the spacecraft's cameras captured a giant heart-shaped feature that caused a collective swoon among countless fans on Earth. I expected Pluto to be a scientific wonderland, but it did not have to be so beautiful, says Leslie Young, a planetary scientist at the Southwest Research Institute in Boulder, Colorado, and a deputy project scientist on the New Horizons mission. Although scientists caught that first jaw-dropping glimpse nearly 5 years ago, they are still seeing images of the world for the first time. When New Horizons reached the dwarf planet, the craft was moving at 52,000 kilometers per hour. So fast, it was able to capture close-ups of only one side of Pluto, the hemisphere that the sun illuminated at the time. The other was temporarily shrouded in shadow. Now that scientists have scrutinized those near-side close-ups, they are beginning to analyze the other half, which the spacecraft photographed days before it shot past. Researchers call that hemisphere the far side, or even the dark side. Although the images aren't as clear as those taken later, in which features as small as roughly 75 meters can be seen, they still reveal terrain at resolutions ranging from 2 to 30 kilometers. At best, that's 250 times better than the pictures shot by the Earth-orbiting Hubble Space Telescope. It's still really juicy data to look at, says Harold Weaver, a planetary scientist at Johns Hopkins University in Baltimore, Maryland, and a New Horizons project scientist. And it's the best we'll have for another 30 to 40 years. That's assuming another spacecraft is sent to Pluto, and soon. With hundreds of images to analyze, scientists have a new view of this active world, one that provides crucial insight into the hazy details of how it formed, whether there's an ocean hiding beneath its icy crust, and the complex ways that compounds freeze out of the atmosphere and sculpt its surface. The data even bolster the argument that the chilly world just might be fit for life. But the images present a set of puzzles. The skyscraper-like shards of ice, for example, were previously seen on the near side, but now appear to circle Pluto. This makes their origin one of the biggest mysteries on the dwarf planet. Pluto is the gift that keeps on giving, says Richard Binzel, a planetary scientist at the Massachusetts Institute of Technology in Cambridge and a New Horizons co-investigator. A splashy start. When Clyde Tombaugh, a young astronomer at Lowell Observatory in Flagstaff, Arizona, discovered Pluto 90 years ago, it was a speck of light barely visible to the largest ground-based telescopes. It wasn't until 1988 that a chance alignment gave astronomers a lucky break, when Pluto happened to cross in front of a distant star. As the starlight filtered through Pluto's atmosphere, scientists were able to disentangle the molecules there, including nitrogen, carbon monoxide, and methane. Then in 1996, the Hubble Space Telescope helped scientists to finally see surface details at a resolution of 500 kilometers. Although fuzzy, the images reveal a world, at that time still defined as a planet, that had more large-scale contrast than any other in the solar system. except Earth. It was a tantalizing hint that suggested Pluto might be a dynamic world, and was quickly verified in July 2015, when New Horizons famously spotted a heart-shaped feature just north of the near-side's equator. Within the heart's left ventricle is Sputnik Planitia, an icy basin, churning and flowing with massive glaciers, that scientists now know exerts an extraordinary influence over Pluto's activity. As sunlight warms the frozen plain, a pulse of ice sublimates into vapor that wafts upwards, before dropping back down at the end of the day. The heart might have even knocked Pluto on its side. Shortly after the first images of the near side arrived at Earth, Francis Nimmo, a planetary scientist at the University of California, Santa Cruz, and his colleagues realized that Sputnik Planitia was in a strange place. It is aligned almost exactly opposite Pluto's largest moon, Charon. It could be an accident, but the likelihood of that is a mere 5%. Instead, models suggest that when the basin formed, an underground ocean began to well up into the chasm. Afterwards, nitrogen gas in Pluto's atmosphere condensed and froze in the frigid basin. The weight of the new water and ice created a heavy load that tipped Pluto into its current alignment. The idea of a subsurface ocean has existed for some time, but the far side images have helped to bolster this idea. Some of the strongest evidence comes from a feature known as chaotic terrain, a muddled mess of ridges, cracks and plains, on the exact opposite side of Pluto from Sputnik Planitia. Scientists have seen such pairs before on Mars, Mercury, and Europa, one of Jupiter's moons, where they suspect that a collision from an asteroid or a comet sent seismic waves racing through and around the body. Once those quakes converged on the opposite horizon, they tore up the surface in ways resembling what appears on Pluto's far side. To test the origins of this chaotic terrain, Adine Denton, a graduate student in planetary geology at Purdue University in West Lafayette, Indiana, simulated how an asteroid impact would send shockwaves across the dwarf planet. The work, which was presented virtually at the Lunar and Planetary Science Conference this March, verifies that such a collision would have created the terrain, but with one caveat. It would have been possible only if Pluto had a 150-kilometer thick subsurface ocean of liquid water. Oliver White, a planetary scientist at the SETI Institute in Mountain View, California, who built a geologic map of the far side, but was not involved in the study, argues that although the feature does seem to resemble those seen elsewhere in the solar system, the resolution in the image is low, and other scientists agree. We will never know until we go back. Someday, says William McKinnon, a planetary scientist at Washington University in St. Louis, Missouri, who is deputy lead of the New Horizons geology team. All cracked up. That's all I have for you guys for today. If you liked watching this video, please make sure to click the like button, subscribe to our channel, and click the bell icon so that you may be notified when we upload a new video. Thanks for watching.